As I said, we have three outstanding speakers today, and it is my distinct honor to introduce our keynote speaker, Dr. Timothy Lyons. Dr. Lyons is a distinguished professor of biogeochemistry in the Department of Earth and Planetary Sciences at the University of California, Riverside. He is director of the UCR Alternative Earth Astrobiology Center and the Wilbur W. Mayhew Endowed Chair of Geoecology. He is a fellow of the Geological Society of America, the American Association for the Advancement of Science, the Geochemical Society, the European Association of Geochemistry, and the American Geophysical Union. Among his honors, he received the Arthur L. Day Medal from the Geological Society of America and the R.M. Garrels Award from the Geobiology Society. Dr. Lyons has held numerous visiting positions, including Liverhome, Bass, and Hans, visiting scholar appointments at Cambridge and Yale University, and the Max Planck Institute of Marine Microbiology, respectively. He was an honorary professor at the University of St. Andrews. He received his Bachelor of Science degree in Geological Engineering from Colorado School of Mines and his doctorate in geochemistry from Yale. Lyons specializes in geobiology, biogeochemistry, and astrobiology, with particular focus on the coevolution of life and Earth's surface environments in deep time and the implications for life beyond our planet. He emphasizes early oxidation of the atmosphere and oceans and co-commitment impacts on nutrients in the bioessential trace metals. His interests extend to the environmental conditions that could favor or challenge the origins of life. And at the other end of the time scale, he studies ecosystem destruction and the impacts on human health in regions with shrinking terminal lakes and thawing Arctic permafrost. We invited Dr. Lyons here today because we are at a critical juncture. We are witnessing a troubling trend of funding cuts to scientific research by the Trump administration, a move that threatens to stifle the innovation and discovery that keeps our nation at the forefront of the global community. So please join me in welcoming a brilliant advocate for truth and a dedicated defender of the scientific enterprise, Dr. Timothy Lyons. Dr. Lyons?
Thank you so very much. Let me start by asking two questions. Can you hear me okay? Yes?
Yes, a little louder, I guess.
I can't do much on my end, but you might be able to turn it up on yours. Test, how's that?
Okay.
Okay, and you can see my slides, correct?
Yes, we can.
Okay, great. Just making sure, because I do a lot of public addresses, and sometimes you get about 20 minutes in and someone says, you know, we can't hear you. So I wanted to make sure. Thank you for that wonderful introduction, some of which I sent you. But that's the way these things go. But thank you for reading it so well. And thank you very much for this invitation, which was catalyzed in part because I think Lewis contacted our press office, and I very recently wrote a Q&A on NSF-related cuts, and that got some wide distribution. And so things lead to things, and I'm really honored to be here today. Thank you so much. I'm going to take a little bit of latitude and take you through a narrative that's maybe a little bit longer, not too longer, much longer than you're used to, but just to give you some context of what my story was like, because it's so different than the way things are now. And I'll end with where we are now and how really impossible it would be to recreate the trajectory that I was able to benefit from. And I'm going to give you just a little bit of a primer on some aspects of climate change, which are so central to so many of the things that I end with in terms of funding cuts, because you all know that any research related to climate change has been consistently and preferentially in the bullseye, among other things, but that has been targeted in particular, including many colleagues of mine who have lost grants. So the overarching motivation here is really to talk about some really essential things that are are prominent in my research. And when I think about the ancient Earth, but increasingly about the modern Earth, and that is water and food and health and the intersection of all of those things as related to climate. And I have energy outside of that Venn diagram because, to be honest, I worry a little bit less about energy than I do about water, for example. Partly because when we finally get it together and realize how much the sun has to offer and other sources of renewable energy, that we'll see that we're probably going to do okay, especially if we stop pumping all that CO2 into the atmosphere. And so I, like many of you, grew up during a really wondrous time, and it launched me into on a trajectory towards STEM career. And I was a young boy, but I can still remember going through all of these exciting missions and sitting in the back of a classroom next to a TV as the first steps on the moon were taken. And so NASA has been in my life, and science has been in my life for entirety. And I had very supportive parents who made all of that possible through summer programs and taking me in the field to collect minerals and a variety of other things. And so as was mentioned, I started my career in geological engineering, and I was trained, like almost everyone at the Colorado School of Mines, to think about finding minerals or petroleum, not for philosophical reasons necessarily, but that was not the trajectory that I wanted to follow. And so I instead went to Yale and studied the modern Black Sea, which is quite a remarkable place. Some of you will know this, probably most of you will not, that it's the largest portion of the ocean today that is completely devoid of oxygen other than the surface most layers. It's 2 kilometers deep, and almost all of that water is free of oxygen and containing rotten egg smelling hydrogen sulfide. And while that's rare today, that is the condition that dominated the oceans for almost all of Earth history. And so I really got quite lucky that I stumbled upon this project when I was at Yale. And little did I know that it would set the course for the research that I am doing for the rest of my life, including the search for life beyond our own planet and our own solar system. So I've used the modern Earth to understand the ancient Earth going back billions of years, and as I just alluded to think about how we might develop tools that would enable us to look for life elsewhere within and beyond the solar system. And so many of these things are just fortuitous. As I was presenting on my results from the modern Black Sea, a colleague came up and said, "You should look at our very old rocks in Glacier National Park. If you've never been there, you must go. It's one of the most beautiful places, not only in the US, but the world. And it has rocks that are about 1.4 billion years old." And I thought that this would be just one step into this very ancient world and it may not be followed by others. But I had been lucky, I should say, with NSF funding when I was doing my PhD. And while I was a postdoc at University of Michigan, I wrote another grant to NSF and was fortunate to get that funded. And then, these rocks, this ancient chapter of Earth history represents about 90% of our archive, from 4.5 to about a half a billion years ago. And so when I was just starting my first faculty position, there were a series of papers that came out in the journal Science that each made a claim using different geochemical and physical evidence for life on Mars, using this meteorite that is shown here, the famous Allen Hills 84001, collected in the Antarctic. And in the subsequent year or so, each one of those claims for life evidence or biosignatures was challenged effectively. And NASA realized that it was not particularly adept yet in this very difficult search for life beyond our own planet. And perhaps the best way to develop those skills was to focus with even more intent and more money on the early Earth. When you go back billions of years, recognizing signs of life even on our own planet can be very difficult. So again, just, I would say, a lucky step to be in the right place at the right time. And the NASA Astrobiology Institute was spawned in 1998, 2 years after the Allen Hills papers came out. And astrobiology still thrives, less so now in the present administration. I'll talk more about that at the end, but it still thrives within NASA. And it has really four primary targets. One is habitability on ancient Mars and science for ancient life. And you all follow it with great interest, I think, the Curiosity and now Perseverance rover missions and many other assets that have been sent towards Mars and orbiting it. The icy moons of Saturn and Jupiter. So in particular, we're very interested in Europa and Enceladus, and there's a mission heading to Europa right now. And then the subject that really captures my interest are the exoplanets. These are planets around stars other than our sun. And so it can be argued based on star forming processes that probably every star we see and those we don't see have planets, in many cases more than one planet. And so a near infinite number of potential targets, and the great challenge is to figure out if there's life on these distant worlds in places that we'll never visit. So it's about characterizing things remotely. And at the bottom left, you see that the origin of and nature of life on our own planet is a driving force in our understanding as we develop these missions. And so about 10 years ago, we developed the Alternative Earths Astrobiology Institute at UC Riverside, exploring 4 billion years of persistent habitability on a dynamic early Earth. So in other words, using these many different chapters of Earth history, because our planet has evolved so dramatically over time, from one with a not very bright sun to the present day sun, an atmosphere without oxygen to one with 21% oxygen, a hot interior to a cool interior. And so we can slice the Earth into these different pieces and think about what the atmosphere may have been like at those times and what the gases in at those atmospheres might have told us about the life in the oceans beneath. And so again, being able to, through the grace of this wonderful funding arrangement that we had within NASA and NSF and the coupling between those two agencies, we were able over a couple of decades to basically parlay a growing body of knowledge about our own planet to drive mission-specific searches within NASA. Again, something that would be very difficult to do in the present climate. And so for those of you who are interested in exoplanets, you have to update the count probably about every week. There are almost 6,300 now confirmed planets. And as I said, probably every star has planets around it. So we have massive numbers of targets. And right now, brilliant colleagues are designing what's called the Habitable Worlds Observatory, which will be an atmosphere characterizing machine looking specifically for biosignatures in these distant worlds. And so in recent years, I've been trying to take these sort of basic curiosity, are we alone, where did we come from questions, and do a little bit more for even more. I think that's a great service to society, but a little bit more hands-on in addressing the world we live in the face of catastrophic change. And so I've been working close to home in the Salton Sea. Some of you may remember when the Salton Sea looked like this back in the 50s and 60s, and it was touted as the next great resort area. And then, of course, as the lake level rose by the 80s, this is what it looked like. And if you looked in detail at the figure on the right, what you would see is the salinity in the Salton Sea, which has water draining in through agricultural outwash, but has no outflow. The salinity is twice the ocean. And the lake level is dropping dramatically, particularly starting in 2003 when there was something called the Quantitative Settlement Act signed. There are many different stakeholders that are competing for Colorado River water. And so the Salton Sea is getting less and less, and it's becoming a massive health risk for the region. And so this is what it looks like from the air. Imperial Valley is one of the large agricultural regions in California. And the water has been flowing there into the Salton Sea from the agricultural fields since the 1920s with zero treatment. The Salton Sea was designated as an agricultural sump, which meant that any wastewater could go in there without any concern for what was in that water and any expectation that the water would be treated. And so not surprisingly, 100 plus years of fertilizer-rich agricultural runoff has led to incredibly nutrient-rich, or what we call hypereutrophic conditions. And every summer there are algal and bacterial blooms, massive amounts of life within those surface oceans. Think the reflecting pond in Washington. And so what we're starting to discover is that these bacterial blooms may be the principal source of the sickness on the margins. The the surrounding communities suffer significant respiratory distress. It has a many time over California average abundance of non-allergic asthma rates, especially within young people. And so that, it's a growing problem, and there are a lot of people working there, and there's been really no solution proposed, despite different strategies that could cost up to $10 billion. And so the fish die in the summer because the oxygen is consumed, um, and hydrogen sulfide mixes upwards. And people who grew up in LA through these years will remember when the hydrogen sulfide, the rotten egg smell, wafts all the way to the Pacific coast. It's been reported as far west as Ventura, and that's all coming from the Salton Sea, and it's all related to this agricultural runoff. So we've been working as part of a task force at UC Riverside and with many colleagues on and off campus, trying to first and foremost figure out what the principal antagonists are in terms of compromising human health in the region. And at the same time, trying to figure out how to protect the ecology for the waterfowl, et cetera. And so the worst case really is that potentially is that it will eventually dry up, as we see here at Owens Lake, which was the largest producer of what's called PM10 dust in the US for a while, until they started mitigating against some of that with vegetation and wetting. And so we were on the front page of the LA Times not very long ago, because against the backdrop of all this health risk, ecological risk in the Salton Sea, there are, as many of you will know, reports of massive lithium reserves within the hydrothermal fluids, the geothermal fluids that have been providing power for many years. Those fluids are also enriched in metals, and enriched in particular in lithium, by some estimates $500 billion of reserves. And so through a congressional earmark, I was fortunate enough to be able to build a lab that was just completed down in Imperial Valley College, that first and foremost is designed to take kids, young people, anyone really from that region, and to train them for high-end workforce opportunities in the labs of the lithium industry, but more broadly, to give them opportunity with a very high end of training. That's a $700,000 lab that we put in down there, very high-end training for conversion of 2-year degrees to 4 years degrees in graduate school, and work in the private and public sector in many different ways. And very recently, and there's been a lot of press about this, we've been working, and again, just sort of serendipity, I saw a picture of this on something that popped up on my computer, clickbait, about these rivers in the Western Brooks Range, some of the most pristine waters in the world, far removed from populations other than some sustenance communities of the native populations. And so what's happening is the permafrost is thawing, oxygen is penetrating through the thawed permafrost and oxidizing minerals, much like happens at mines. Some of you will have heard of acid mine drainage. And so this river that you're seeing here is orange from iron and other metals that have been released from those rocks in ways that have not been reported before. And it's changing dramatically on just yearly timescales. So we got a small amount of NSF grant money to work on this before the present administration. It may have been hard to do that in the present form. And so just the very regrettable reality is that, as you all know, climate is changing, and some of you may not know some of the details, and I could give many, many, many lectures on this, but you will have seen CO2 curves that look like this. This is the year 1000 on the left side, and here we are at the present on the right side, and you see a dramatic increase around 1800, which of course is the Industrial Revolution. And so I teach a class called GEO2, which is an Earth Systems class, and it's meant to inform the students about what humans are doing to the Earth, but against a backdrop of what the Earth does naturally. So I don't think you can understand one without knowing the other. Otherwise, the risk of making false claims is very high. And so when I teach this class every year, I have to update from this important archive, co2now.org, the CO2 level of the atmosphere. And so every year it goes up by about 2 ppm. And so I'm going to go through this quickly. But the shocking thing is, I'll give away a punchline, that the CO2 level should be about 300 ppm were it not for the Industrial Revolution. You can see that here on this chart. And so we're well over 400 now. And so I'm going to take you through my yearly struggle that I have to go through with these students. And so the initial measurements were made by a scientist at Scripps Institute at UCSD. And now we have these CO2 monitoring stations, for now anyway, all over the world. The atmosphere mixes in about a year, but we want to get away from city effects, anthropogenic effects that are proximal. And so we have a global CO2 curve that is incredibly robust. And so here are these numbers. You'll see an increase, and I'll go fast through this, but in 2015, we struck something that I was shocked and I didn't imagine really in my lifetime that we would. We went over 400 ppm. And then I just keep updating each year. This is literally each year until we are now in 2025, December, it was 427 ppm. Shocking. And so my father, who sadly died at 92 years old last year, he knew enough to be worried, but he didn't know enough to why he should be really worried. And he would hear things about natural drivers of CO2 levels and climate change. And so I sat down with him with a coffee once and said, Dad, you know that we have records, really detailed records going back very deep in time through models and other what we call proxies, geochemical techniques. But over the last few million years, we have really direct measures of CO2 in the atmosphere because we can look at bubbles and ice cores. And so what you can see here is it goes back now again a few million years, but you have a 400,000 year record. And then you can see the jump of the Industrial Revolution where it's now up, as I said, well over 400. And so this natural variation is what the Earth would be doing. We understand this, and I teach this to my students. It has to do with the orbital relationships of Earth and the feedbacks controlling CO2 and driven by CO2. And so we know what the Earth does naturally, and that's not what's happening now. And so not surprisingly, the 10 hottest global years on record, we're going back here, this initial figure, and I update this each year too, go back to 2010. NASA said that 2022 was the 5th warmest year on record. The warming trend continues. 2023 was officially the hottest year ever recorded. Scientists say the temperature will keep rising. 2024 set a new record. And so 2024 was the world's warmest year on record. 2025 was one of the top 3 warmest years on record. And what was so striking about the 25 warming was that it pushed the global average temperature past the critical 1.5 degree C centigrade threshold, which is something that has been part of the Paris Agreement. We wanted to stay below 1.5. Now people are saying, let's stay below 2. And dramatic things happen to the Earth as we take each of these half-degree steps. And so we are now at a point where we're pretty close to consistently being over 1.5. I had to make this timely. And so in the lower right is a Norwegian player who purposely took the number 2 because he was thinking of the Paris Agreement, now 2 degrees centigrade threshold. So the whole world is with us in many cases, more on top of this than our present administration is allowing us to be. And so sea ice is declining, the lowest report on record in 2012, but you can see a steady decline in sea ice. And glaciers are receding. Sea level is rising. The predictions for how fast it will rise depends on what we do about climate. If we don't do much, if we continue business as usual, or even back to conditions that were even worse than what we're doing now, which is certainly possible, then sea level will rise, and low communities, Pacific Islands, and a number of different regions in the world are already experiencing these problems. The other thing that's happening, of course, and this is well measured around the world, in this case, a station in Hawaii, the pH of the ocean is decreasing because the CO2 is increasing, which creates acidic conditions. And so this affects the ability of corals and other organisms to create their skeletons. And so the question is, what are we doing about this? And this leads into the discussion that I'll end with about the agencies. The Biden administration did the best that it could, and it steered a lot of interest away from coal burning power plants. And so through a reduction, as it says here, coal-related CO2 emissions declined by 10% from 22 to 23. And so there was a significant, a 3% reduction in the gigatons of CO2 released by our country. So, not a dramatic change, and yet you could already perceive it. And the red dot that you're seeing on this figure is what happened by 2025 with the new administration. We essentially lost all of that gain within that very short amount of time because much of the effort was turned back to fossil fuels, coal and petroleum. And so the big dilemma, which for me is really very interesting, I think, is that we always prioritize short-term concerns over long-term crises. And perhaps that's because that's the only way to get elected. If you don't talk about the price of eggs or the price of gas and what a problem that is for all of us, then you're not in tune with the public. And I freely admit that. But somehow we as a population have to acknowledge that those are just little blips in the grand scheme of things relative to what we're doing existentially to our world. And so the bed of roses, admittedly, we're not living in a bed of roses, but the Dow is at 52,000. Unemployment rate is at 2%. By many measures, other than the things that we're talking about here, our economy, we're doing okay, and okay enough that it's long past time that we acknowledge that there are bigger issues that will affect not just us, but our children and their children and so forth. And so let's just talk about what the agencies are doing. And this is just sort of capturing what I was saying there, that when eggs are high, and you can see that they rose and they fell, it's a transient feature, but it sways so much of how we vote. And we end up with an administration that is not only condoning, but advocating and strongly supporting a return to coal-fired power plants and drill, baby, drill. Just staggering to hear these things, especially for someone who does what I do. The economic opportunities lost are perhaps the things that are most heartbreaking. 60 to 70% of the global EV production is in China. 80 to 85% of solar panels are produced in China, and 50 to 70% of wind turbine components are made in China. We could have done all that. But instead, what this administration has been doing is rejecting the notion for just a completely silly reason, renewables like wind. Happily, there was a recent court victory, which is putting this back on the table. But it's this constant struggle of an arbitrary and really destructive decision being made, leaving it to the courts, at least temporarily, to slow that pace. And so some things that are even more dramatic than this, perhaps, is that we immediately pulled out of the Paris Agreement, which is a global accord with the constant coordinated effort globally to not cross these thresholds of 1.5 to 2 degrees centigrade. And then when I was teaching my GO2 class in February, this happened, and it was just ripped from the headlines that the endangerment finding was rescinded. And so that stems from a 2007 landmark Supreme Court case, Massachusetts versus EPA, where the U.S. Supreme Court ruled that greenhouse gases qualify as pollutants, and that they directed the EPA to determine whether these gases were endangering public health and welfare. And through 2 years of painstaking, really careful science, they did that work and determined that, of course, in fact, these gases, CO2 in particular, are harmful to humans, and they set vehicle emission standards, which are all gone. They're all gone. And so this is being fought in the courts as well, but it's a very, very difficult struggle. Again, for someone like me, and many of you too who follow these things, it blows the mind. And it creates, just as I said before, existential is a word I use very often. Another story that popped up recently, it's like I wake up every morning and think, who even thinks of these things to do? They went after the National Center for Atmospheric Research, the famous NCAR. I lived in Colorado for 4 years. It has this beautiful setting against the Flatirons up in Boulder. This center has existed since 1960 and has really been the preeminent facility for research in climate and weather, including extreme weather. So it addresses modern phenomena in terms of weather, but also longer term trends in terms of climate. It is a one-of-a-kind facility because of its supercomputing capabilities. It has had 800 people dedicated to weather and climate science. generating data that have been distributed around the world, collecting data as well as processing them through computational methods. An important training ground for the next generation of leaders. There is a federal injunction, again, ripped from the headlines as of June 1st. So the closing of this is on hold right now, but the Trump administration has already been talking to different organizations about how to dismantle it. But for the time being, anyway, that's not happening. Unbelievable. And so going now in the final slides, looking at where the money is in all of this. The National Science Foundation, for those of you who don't know, is really our bread and butter agency for basic discovery research across all scientific disciplines. We have many agencies that do tremendous laudable work, and in many cases they're charged with more applied research, like the Department of Energy or Department of Agriculture. The National Science Foundation is basic discovery, blue sky research that in many cases would be the first steps towards incredibly monetize discoveries that can be monetized and advance society in so many different ways, but steps that are not specifically product oriented in terms of something you might put on a shelf, asking, again, very creative, very basic questions. And so you can see from this figure awards made in 2026 relative to the other years. Shocking. The effects of this are rippling throughout the community. Early career scientists are saying, what should I do? Should I even consider doing this? And here you can see inflation corrected dollars 2026 versus the other years. And so everything I described to you at the beginning, this path that I took from doing risky science, that was something fundamentally new to me, I was able to get it funded and build across all of that, from National Science Foundation, eventually to NASA, from a $200,000 grant ultimately to $13 million of NASA money to try and advance the science for ourselves and for society. And so this is what it looks like most recently. This is in current dollars. The budget is it's been pretty flat for a long time, if I'm going to be honest. And so it rose a little bit during the Biden years, thankfully. And thanks to the CHIPS and Science Act, there was incentive for it to rise up to as much as $18 billion. It never quite got there, but that administration recognized the importance of the basic discovery type research that the National Science Foundation does. And so the most recent budget has taken that and reversed the trend. And the initial ask was for only about $3 to $4 billion. $3 to $4 billion. And so and when we do this with inflation correction, you can see that there hasn't been much of a rise through the years. There was a bump from the CHIPS Act, but really that if that happens, it'll be devastating. What I will tell you in a second is that these numbers are always thrown out, and happily Congress debates these things, and often the numbers are restored, and so it won't be $4 billion. It'll be something higher. But the insidious thing is that what money goes to different things. It's not back to those basic research programs. It's under different guises that affect the community so profoundly. And this is an old thing to do, but I couldn't help, especially in the present administration. The current ask for the Department of Defense is $1.5 trillion, and the initial request was $4 billion for our most fundamental discovery-based science wing. What can you say? And so these stories come out all the time. You have to keep up on it so much because it's such a moving target, and the judges come in and there's a stay and then it goes back and it's all in the courts. I'm not a political scientist, but I have to stay close to this. This just came out in June 22nd. And so NSF will cut hundreds of science programs by 30%, even though the net budget cut is only 3% once it's restored from that very low $4 billion number. But if you read between the lines, and this is what you always have to do, there is nested with that a completely different reallocation of those funds towards very, very, very applied science, developing centers of tech development, which is fine, but that's not fundamentally what the National Science Foundation is. And there has always been a big bullseye, as I said, on climate research. And so just quickly to go through this, sources say they suspect the goal to free up funds is for new initiatives to produce products and industries. A former member of the now defunct National Science Board, so the Trump administration dismissed the 22-member independent board of the National Science Foundation. This member was troubled by both the cuts to basic research and the applied focus of new initiatives, noting that NSF's mission is to support discovery research, which is also the basis for much new technology. And so this scientist down at the bottom comments that even scientists who agree about the need for more quick translation of basic research into societal benefits, this scientist was dismayed because he or she didn't realize that all that money would be taken from other directorates. So these fundamental core programs where you can write a single PI $200,000, $300,000 grant to get your footing and build and build and build towards large science with high impact, like my group has been able to do. That stuff is all gone. It's just essentially all gone. It's just gutted. It doesn't look anything like it used to look, and everyone's heads are just basically spinning. NASA funding has been flat for many years. It's higher than National Science Foundation. It's usually protected because, as I like to say, almost nothing crosses the aisle better than space science, whether it's human missions to Mars or whether it's the Artemis mission to the moon. These things tend to be relatively immune to capricious cuts. However, the money is spent in very, very different ways. And so I think this is really shocking to show you how our country has changed over the years and how it's valued science. If we inflation adjust during the Apollo era, we were spending $70 billion a year on NASA. And so here now in this inflation adjusted numbers, you can see the proposed cut. It's pretty dramatic. These are not big numbers, especially if you compare them to the defense spending. And so here is the percent of total national budget, federal budget spent on NASA. And so during the Apollo era, and we know what that accomplished, it was 4% of the total federal budget. And now the NASA budget is just a tiny fraction of 1%. And it is vulnerable, as I said here, we're already seeing significant cuts. So science of all sorts, particularly things related to climate science, are in the bullseyes. And so 1 year after Trump, Nature published a review article, and these numbers are difficult because it's hard to know and keep track, and there are threats of big cuts, and then the courts fight, and some of the money is restored, but there are top groups working on just trying to track really what's going on, and Nature would be among those. And more than 7,800 researcher grants were cut a year after Trump came into office. 25,000 scientists and personnel were gone from federal agencies. Proposed budget cuts of 35%, sort of across the board, manifesting in different ways, up to equaling to about $32 billion. They did this by canceling grant reductions. You might have an award, but it becomes smaller, or you received a letter saying you were going to receive an award, and then they said never mind. Squeezing the pipeline for new scientists during the 2025-26 academic year. New international student enrollment at U.S. universities fell markedly. That was a visa issue, but also why come here if there's no money? And so gutting science agencies as well. And that's what we're seeing here. So this is from 2015, 2016, all the way to 24, 25. And so you can pick your favorite agency: Center for Disease Control, Department of Energy, EPA, NASA, National Science Foundation. And so these are agency staff levels change from the previous year. And so here is what the Trump administration has done. Through DOGE and through many other things. Many of my colleagues at NASA, for example, were not DOGed, but they simply said it's going to be too hard of an environment to do the kind of science that we want to do. And so I'm going to leave with this thing. I tend to get very nationalistic sometimes. That's a bad word to use, but I'm very proud of my country, and I'm very proud of the science that I've been able to do in my country, and the support I've received from federal agencies and from so many different directions. And I feel such pain for the people that are starting their careers now. I looked at my CV and I reminded myself that I've had 60 postdocs and graduate students, many of which are at top universities, professor, Georgia Tech, Virginia Tech, Purdue University, Yale University, on and on and on. And they are losing grants. I actually texted my student who's now a full professor at Yale University, and he said that his money for carbon capture was completely shifted. It was cut, but in an insidious way. He was working with farmers on using soils to capture CO2 from the atmosphere. And so he was partnered with agriculture in a really terrific way. And so the money was shifted all to the farmers because that made great press, but the farmers had no idea what to do since they didn't have the postdoctoral support and the analytical support from the people at Yale University anymore. So it created, and this is kind of a recurring theme, it creates a complete destabilization of any understanding of how the science that was proposed could ever be done. And if it is done, how it could be continued in light of the low probability of getting grants renewed. And so I find it's a little bit of a pretentious measure, but I think it's quite telling because it shows a lesson for something that's happened in the past. And it's the Nobel Prize is awarded by country. And this is a really difficult metric to use because prizes are shared and do they have to be a citizen? And I'm not going to get into the weeds of all of that. I'm just going to make my first order point. And if you look at from the year 1900 to the present, there's something that's really striking, and that is that you see that Germany really dominated. And the list of scientists and science that was being done in Germany pre-Second World War is astounding. Many of the most famous scientists in 20th century history. And then the war changed everything through death, through people escaping, through the loss of infrastructure, through the deprioritization of peacetime application of science. Germany actually never really recovered. And so I was so disheartened, being mostly of German heritage, to hear that their finance minister is investing a lot of their future on retooling plants that maybe were making fancy cars and other extraordinary feats of engineering into weapons. So that's sort of where their future is going because they missed some real opportunities to invest in high tech. They don't have an equivalent of Silicon Valley, just engineering excellence and chemical excellence that has not kept pace what's happening in the rest of the world, the US and now increasingly China. And so you can see the increase of US Nobel Prizes. And so then as of 2025, the US has 428 Nobel Prizes, and the German number has increased by maybe a factor of 4 since pre-war times, in the US by a factor of 20. And here's the thing that I think is most important and I'm most proud of is that 30 to 40% of the US awards awarded to personnel at US universities and institutions are immigrants. Some of them are citizens, some of them are not, but they were all drawn to the promise of what it is to do science in the US. And I can tell you now that they're not coming. And that includes the Chinese scientists that have done wonderful science here in the US and stayed in the US and advanced our science and our initiatives and our agendas. So it's everything is changing. And so I'll end with just like all of you, I wake up and I read the breaking news, and I wish I didn't. Everything I read about controlling anxiety says that make sure that you've had your breakfast and a cup of coffee and done a number of different things, including hugging your family before you read the news. But I often have difficulty doing that. And every once in a while, I get a little bit of Schadenfreude. That is an evil bit of happiness that you get from the suffering of others. And so in this case, usually I don't get Schadenfreude very often, but in this case, it's about this dreaded algal pond. And so I think, this is like the Salton Sea. I could have told them what was going to happen. The lesson is the high price of action and reaction without knowledge and common sense. It just happens over and over and over. The dough balls are thrown at the wall, and some of them stick, and the courts pull some of them off. And it's just this constant struggle. And early career scientists are just spinning around, wondering how they could ever have the good fortune that I had to have the career that I had. And so I'm also drawn to this quote, "What fresh hell is this?" from Dorothy Parker. I feel that every day, as I'm sure many of you do as well. So there is my email address. Don't hesitate to write me if there's any questions you have. And we have some Q&A time here, I think, or maybe not. But either way, feel free to write me. And if you look at UCR, if you just do UCR, NSF, and then my name, you'll see that piece that I wrote, the Q&A about it was particularly focused, specifically focused on the dissolution of the advisory board within the National Science Foundation. Thank you for listening.
Thank you, Doctor. Doctor, I was just wondering, wasn't the reflecting pool vandalized? Wasn't that the?
Yeah, that's what I heard
Yes.
too. Yeah.
I think we have time for a few questions, and I see Fraser has one right up front. Let's get the mic, Fraser, so that people online can hear you.
Thank you for your excellent presentation.
My pleasure.
From my understanding, the fossil fuel industry would have us believe that the rise in CO2 is related to either volcanic eruptions or decaying vegetation. And I believe because of the different isotopes of carbon that you folks can successfully figure out where the CO2 has come. And the conclusion has been, I believe, that it's overwhelmingly from the burning of fossil fuels.
Overwhelmingly. They're just all red herrings that people throw out. And the problem is that most people, if I'm being honest, don't have the capacity to analyze that. If you do radiocarbon analysis, for example, which has a half-life of 53 years and is famously used to date archaeological tools, it goes back with its utility about 50,000 years. There's actually an effect that has to be corrected for, which has to do with the burning of fossil fuels because they're old and they have no radiocarbon in them anymore. So the carbon 12-13 ratios, the carbon 14, all of those things. In fact, I didn't know this until quite recently. I'm most known for my studies of oxygen in the atmosphere over time. And if you actually look at the data at the stations where they're measuring the increases of CO2, which are so striking, and volcanoes don't do that. I teach about volcanoes. If you think of Pinatubo and some of the other eruptions, they're transient effects. They release aerosols. It's not so much CO2, they release sulfur dioxide that has a cooling effect. But those effects last for a couple of years. It gets up into the stratosphere and the Earth mixes, and you see maybe a fraction of a degree change. There was a famous incident in 1815 for the Tambora eruption, but then a few years later, that all went away. So it has nothing to do with that. It has nothing to do with biomass. And where I was going with the O2 is that the amount of oxygen in the atmosphere, don't worry about it. We have 21%. We're not going to suffocate. But the amount of oxygen has correspondingly decreased as the amount of CO2 has increased, because when you burn something, you consume oxygen. So it's not sunspot activity. It's the natural variation on the scale of thousands of years. While there are periods in Earth history where there have been massive eruptions over millions of years and we had extinction events, that's not what's happening now. Over thousands of years, I alluded to this earlier, the variations are controlled by the tilt of the Earth's axis and the shape of our orbit around the sun, and the fact that our axis precesses like a top. And so you can do statistical spectral analysis of this, and you can tie those patterns of the orbits to observations in the ice cores and observations in sediments collected on the bottom of the seafloor. So we know those natural variations over hundreds of thousands and millions of years. And the truth is that were we not increasing CO2 in the atmosphere through human impacts, we would actually be going into a cooling. We would actually have glaciers actually growing rather than receding as they are today. So don't believe any of it. And if you read these reports from the Heritage Foundation, they string together things that they know people aren't going to be able to understand. And there is always some giant leap of faith where you go, what? And yeah. And that's where these decisions are coming from. The people that went after the endangerment finding, it was a couple of people that had that in their sights. And they produced a report from a few scientists, and that was waiting for Trump on his desk as soon as he was elected. And there went the endangerment finding.
Yeah, of course. Other questions in the room, in the back row.
Thank you. Really interesting. I'm wondering what you think about AI and how that's going to affect
Oh gosh.
water.
I, that's, that's sort of I feel like I should ask AI how to respond to the AI question. I, I do big data work, and so, as a geochemist, we collect massive amounts of data, and we are happy to use, in constructive ways, machine learning, and I'm open to all different possibilities. Um, I'm not a modeler in that way, but I work with people who do, and so I follow it carefully. I think to turn your back to AI is folly. I think that to turn your back on the risks of it are even bigger folly. One of the stories I heard that was most shocking related to AI is that they're talking about putting a data center down in the Imperial Valley, which is maybe one of the driest spots you could ever imagine putting a data center, and the massive amounts of water that are required for those for cooling. So I use AI, for searching information, but I always do it when I know enough about the information to know whether it's a hallucination or not. I've seen horrible things happen with it through student use. Just recently, I'm an associate editor for one of the science family portfolio journals, and so someone I asked to do a review of that paper said that there was about 30% plagiarism that was AI based, and he knew it was plagiarism because it had been drawn from his own published paper. So I think that we're in a time where everyone is trying to figure out what to do with it best. But I'm not an expert on it, but I also don't fear it. I think that you just have to figure out where it fits in your own personal life or your own professional life and use it accordingly, and stay open to the people that are asking the most important questions and raising the biggest flags of concern.
Dr. Lyons, thank you so much for being here today and sharing your knowledge with us. Here's a question.
Yep.
When you think about Donald Trump, I think one of the things that comes to mind is greed. And doesn't he see that advancing science, research, and medicine isn't there a profit in that? Can he see that,
Well,
or is there
why.
some ideology that's driving him that's anti-knowledge, anti-science, the kind of thing that I'm seeing in the Heritage Foundation?
Yeah, I try not to just turn the rant on because that doesn't do any good either. I think that,
but we enjoy it.
yeah, I mean, it's good when I sort of, can close the door and scream or howl at the wind for a little bit. But I think that there are a lot of different things there. I think most of the people who are involved in these random decisions just don't know very much at all. I've often said that if I could teach my GO2 class to Congress over the span of about a month or two, they would probably come out the other side feeling very differently about it. That being said, I've heard from congressional staffers in our own state where they say our Republican member of Congress, is fully aware of the reality and the risks of climate change, but it's not expedient. It's not a wise choice for them to stand on a platform of that. I think, where we really need what we need, this is so cliche to say this, is we just really suffer in leadership. It's just, you need people to be able to stand up in front of Congress or otherwise, and not just lawyers, but people across all these different disciplines who are willing to take an agenda and run with it and say, that's just bullshit. And to just keep pushing and pushing and pushing. And in terms of the monetary incentivization, it's just so logical. That is, from a kind of a strategic standpoint, the thing I find most frustrating. Look what China has done. My God, I've been going to China because they have really great rocks for the time periods that I work on for about 20 years. And I have watched a transformation in that country where they were just doing a lot of copycat science, trying to be like us, to where they are absolutely world leaders. And so when I go to conferences now, there are many people from China that are doing the best work in my field, and that's true across many, many fields. No longer is the gold standard to come to a Western university and study. Now they all want to go to Peking University. No longer do they want to stay in the US necessarily because there's so much money in China to go back. And so even Western scientists are going, some of my colleagues are going to China because they know that they can get their research funded. And so when I was first going to China, the environmental problems were beyond belief. I remember saying to someone, there will be an uprising because Chinese people care about their children as well. But look what they've done. Look how they have, how they have capitalized on green opportunities, renewable opportunities, and applied them to their own country. And so the quality of the environment there still has a long way to go. But they've acknowledged that it's not only a societal requirement and it's a requirement to keep the population happy, but there's a lot of money to be made. And why we didn't take coal workers in West Virginia and say, how about we train you to build solar panels or build the components for wind turbines? I know these things are obvious, but it's like, why don't they happen? It just makes me scream. And so other countries have figured it out. We haven't. And I will never understand. That's why I'm not a politician. I just don't. I just will never understand. And the things I'm saying are so obvious, but how often do you actually even hear people say them? It's like, yeah, I don't know. So yes, there's money to be made. There are massive amounts of money to be made, especially on EVs. Oh my God, massive. They're going to take over the world, right? And solar panels, that we're shipping solar panels to our country in California that are made in China. Yeah. And the talk about, rebuilding industries in the US, you have to understand supply chains. You have to understand what tariffs really do. And you have to understand what industries can be done in partnership with other countries. Maintaining a supply chain that can't all come from within our own country and trying to develop things, as we did with the auto industry and to some great success for quite a long time, it's just all lost. I just don't, if I'm going to rant, I think he just doesn't care. I just think he doesn't care. And he has people that have very twisted ring in his ears. Then he says, sound good to me. And I'll throw it out there and let's see what happens. And the court stops it or not. And it's like every day it's a new thing. I think about the past year and a half, what we've suffered through is just mind-boggling, just absolutely mind-boggling. And maybe the most shocking thing is how much consequence can happen in terms of our personnel, research, infrastructure, even the quality of our air within such a short amount of time, and the brain drain, the fact that it will be so hard, nearly impossible, even with the change of administration, if it keeps on the current course, to ever restore where we were before. And I know, again, we hear all of this, but nothing's happening. So let's hope for the midterms and let's hope for the courts. We're not getting much help for the Supreme Court, but we are from many other courts. And I am heartened because even to prepare this, I revisited some of the things like the endangerment finding and the NCAR closing and like real time, you can see the courts like they're waiting, they pounce in there and they put freezes on these things. And so if you're making investments, invest in lawyers that are doing this work. If you're a lawyer who's retired, do pro bono work because it's helping, right? It's helping. And there are some Republicans that are turning, but it's still not a lot, but we need more.
All right, Dr. Lyons and Reggie, I think we have one question from online before we close. Let's see, it's what about the proposed rule for political control of awards?
Oh my God. Oh, don't get me started on that. Oh my God. So I've been doing this for a long time. So you could probably gather from my introduction that I've done more than a few panels at the National Science Foundation and NASA. So I, for example, led the senior review determining whether the Curiosity rover should receive money for its extended mission. I've done multi-year stints on the National Science Foundation on core programs and special initiatives. I've seen how the peer review process works, and while it's not perfect, it is the very best thing that we could ever have. And the journals work the same way, and the agencies have historically continued to try and make things more and more fair, in particular to support underrepresented groups. And that means early career and other demographics of underrepresentation that you can probably imagine. And so most things are done now in a dual anonymous way. You don't know who's proposing the science, although there are shifts away from that. But that was, I think, a terrific step. You don't know who's proposing it, and they don't know who's reviewing it. And so those panels you spend, and typically for a National Science Foundation, you wouldn't be paid anything other than your expenses. You would spend 10 hours a day with experts dissecting these proposals, not only figuring out if it's good science, but if it's important science. In other words, if the impact could translate into something that could affect other people in positive ways. And I don't mean just about climate science, I mean about the history of the Earth and all the different kinds of sciences that need to be done in that discovery way. Because let's look at my own career. I could never have imagined, ever, that looking at the anoxic waters of the Black Sea would lead me today to talking to you about Donald Trump's administration and permafrost thaw and the Salton Sea health crisis. And so you just need the ability to take people who are willing to work hard and often not make very much, although the UC does pretty well. I'm not complaining too much, but willing to follow these passions and to try and ultimately help people and educate people. We do a seminar series at our Palm Desert campus. University folks are amazing. You all know that. And in private sector, different sectors, people are most of us are good, and we want to do good things for people. And so I do not want Donald Trump making decisions. Well, that's what he just did with the National Science Foundation, right? So they restored much of the budget, but they're taking a lot of that money and just basically making, we don't know, somebody's going to make a decision about many, many, many millions of dollars that will go into some tech center that will be developing God knows what. And who's going to decide that? So anytime you lose control from the masses of people that are always trying to do the right thing. We don't always get it right, but we always try to do the right thing. And the peer review process is set up that way. You do not want to centralize the decision-making process. You do not want to do that. So peer review, when you meet as a panel, is also fed from external reviews, and then the agency itself makes an evaluation. And so you need as many opinions that are bringing as few amount of biases to the argument as possible. So 1,000% against that. It could never be good. And that's where we're heading already.
Well, thank you, Dr. Lyons, for your great presentation. Thanks for joining us today.
Oh, it's my pleasure. Thank you so much for this invitation. I always enjoy it. And reach out if you have any questions or comments. And if I got ranty, I apologize. But I think we're all kind of like-minded here. And so sometimes the catharsis helps. So thank you for letting me have my moment.
Thank you.
Thank you.